All right, now we're going to look at an actual practice problem for we're going to find the absolute minimum value of the function, we'll say f of x is equal to x squared plus 4 on the interval from -3 to 3. Now, if you haven't watched the conceptual video about min and max values, I would stop and watch that right now because moving forward, I'm going to just assume that you already watched it and understand everything from it. So we're looking for an absolute minimum value. First thing we're going to do is locate our critical point. And we do that by taking the derivative, so we get 2x, and setting that equal to 0. So 2x is equal to 0. We divide both sides of the equation by 2, and we just get that our critical point is located at x is equal to 0. Now, real quick, there's something I may have neglected to mention in the conceptual video, right? When we were looking at our hills and our valleys, we saw that those were probably our minimum and maximum values, right? One little thing I didn't mention, right, is that when we have a hill, if you notice, our function is increasing, and then it hits that critical point, derivative is equal to 0, and then starts decreasing again, right? And that's how we know we have a maximum value. And then the reverse is true for our minimums, right? The function is decreasing, right? Function is decreasing, decreasing. We hit our critical point, the derivative is equal to 0, right? And then we start increasing again immediately. And knowing what we know about where functions increase and decrease can help us locate and determine whether our critical point is at a minimum or a maximum value, right? So here's what we're going to do. First thing we're going to do is we're going to draw a little number line. This is going to help us kind of visualize what's going on with our graph. So on our number line, right, let's put our bounds, right? We're going from -3 to +3. We have our critical point, right in the middle at x is equal to 0. And so we just saw that if we know where the function is increasing and decreasing, we can know if our critical point is located at a minimum or maximum value. So that's what we're going to do. We're going to determine on these intervals to the left and right of our critical points if the function is increasing or decreasing. And from the video I made on this, we already know how to do this, right? We're just going to take the derivative, plug in any random point on that interval, and see if it's positive or negative, right? So if our derivative is equal to 2x, right, I'm going to plug in some random point from -3 to 0. My point's going to be -1 because it's super easy to deal with, right? So f prime of -1, right? It's going to be equal to 2 times -1. And we get that that's equal to -2. So we have any number that we plug in here, we're going to get a negative result for, meaning that our function is decreasing right there, right? So our function is probably going to be like this, right? It's decreasing, and then we're hitting a critical point. Now we can't assume what's going on the right side, so let's plug in some number on the right side of our critical point. I'm going to plug in +1. So we have f prime of +1 is equal to 2 times 1, and we get 2, right? So any number here is going to be a positive number. Any number from the interval 0 to 3 is going to be positive. So we see that our function is going to start increasing again, right? It's kind of looking like a parabola. And that's what our function x squared plus 4 is. It's just a parabola, right? So we see that right here at our critical point, we have a minimum value, right? But if you remember from the conceptual video, we had an absolute minimum value on one of the endpoints, right? So we can't just go and say, okay, yeah, we have a minimum value right here. This must be our absolute minimum. We need to test our endpoints, right? So let's plug -3 and +3 into our f of x equation and see what we get, right? So if we have f of -3, that's going to be equal to -3 squared plus 4. So that's 9 plus 4. We get, what is that, 13? And then if we do f of 3, well, we're going to actually get the exact same thing. We get 3 squared plus 4. That's 9 plus 4, which is equal to 13. And if we plug in our 0, we just want to figure out what the actual value is at that minimum, right? F of 0 is equal to 0 squared plus 4. That's equal to 4. Well, it turns out that our f of 0 is actually less than both of our endpoints in the function. So we can say that right here at the critical point, 0, we have an absolute minimum value. If you watched to the end of this video, I really appreciate it. Thank you, and I hope you learned something.